Okay, so I'm Florent, I'm here today and we're going to talk about authentication. So I'll start by introducing who am I, authentication, reminding everyone of the basics because that seems to be forgotten in the industry. And then we'll proceed and do some cargo code debunking, because there are things that I've been saying as a security professional, and you probably will gospel that you've also been preaching to other people that we should probably quit on teaching because it just doesn't apply anymore. And then we'll take specific examples where the threat model and the specific controls that are deployed towards them just don't adequate, and where, for basic use cases and basic things, we really get it wrong. And we get it wrong and we forced the wrong control and the wrong technology onto the wrong parties and the wrong people. And that matters. And then I'll conclude. And if we've got more time, I've got some extra slides about particular examples that Steve was alluding to that may be of interest to the wider community. So who am I? I'm the director of Mata. We're a boutique security consultancy based in the UK. We've been operating for almost 20 years. We do some research and we do drop a few things here and there. Nowadays we create and write products, an Active Directory password filter. So my job does involve passwords. That's not exactly what I'm going to be talking about today because Active Directory and Microsoft in general are not on the forefront of authentication or anything related, at least not with that particular technology. So that's, but that's what I do. And I'm also one of the co-developers behind Freenet. Freenet being a censorship-resistant network. So I care a lot about privacy and things that one might not realize, but are linked to authentication to some extent. So, why am I talking about this? This is actually a very good question. And, partially because Steve convinced me to do a talk about it, but also because, fundamentally, Alex Stamos did and presented some keynote that was very interesting at Blue Hat, where he rightly reminded the audience that the security industry is really, and can be seen like a pyramid or ladder. And most of the problems are at the bottom. Yet the industry and us as professionals, we tend to focus on the top, on what's sexy, what's trendy, what's whatever. But we don't really address the problem most of our base is experiencing. And I really think that authentication is one of those areas where there's a lot to be done and there's a lot to be said, and things have evolved and our mentality hasn't, and it really needs to change because that's the only way we're going to move forward. So, authentication 101. In the room you're mostly professionals, so I'm going to go over the basic stuff, but the basic stuff gets often overlooked. And I think it's super important that we talk about it. So, let's start with costs. Changes are costly. So all the things that I'm talking about today, I'm trying to talk about what's practical. And I define practical by the least amount of resistance, as in something that is actually implementable as opposed to a pipe dream. And if you look into what really the costs of changes are, you'll identify changes that require process changes. So that means involving the users, involving different parties, involving the operators of service. These are not cheap. So these we should try to minimize. Changing protocols is doable. We've managed to. And we do manage to. If you look at SSL and TLS, we've made a lot of progress in the last decade. We've stalled for a very long time, and then people realized it was important. I myself was talking about forward secrecy back in 2013 when most people didn't know what it was. And nowadays I'm amazed, but we all have TLS 1.3 when we connect to most of the web as a decent version of TLS, and usually forward secrecy. Things that, not so long ago we just couldn't get. But that takes time and that's also expensive. Now, code changes that you operate and that you only do on one side of the equation are much easier because these don't impact the wider ecosystem as much. And that's what most of my talk will be about today. Changes that you can do today that will change the security properties, but won't necessarily be impossible to deploy. And then the last argument is about simplicity. And I completely appreciate this one, where most of the stuff I'm talking about today is more complicated than what the current status quo is. The current status quo is misunderstood, misapplied, whatever, however you want to qualify it, but it has the advantage of being simple. I'll get back to that. So yeah, to make it practical, you need to require as few changes as possible. So authentication, traditionally, we talk about different phases. When we say authentication, what we really mean is different things. And that seems to have evolved, and the interest around those phases evolves over time because of compliance requirements change. So traditionally in the security world, you've heard about the 3 A's: authentication, authorization, accounting. That's the very standard way of approaching things and of thinking about things. But one of the phases that's missing and that is becoming increasingly relevant is identification, a phase that comes before that. So I identify you where I'm trying to figure out who you're supposed to be or who you are. Then I authenticate you to ensure that you are the person you claim you are. Then I authorize you. I check whether you have the privileges, the credentials, the rights to do the action that you want to perform, and then I account for it. I mean, it's really a wall. And today, to keep it simple, I'm only talking about authentication. I only have 45 minutes. But you need to keep in mind that all of that is in scope. Security-wise, we usually care about authentication, authorization, accounting. We tend nowadays to start to pay attention to identification for privacy reasons. GDPR, whatever the keyword of the day is. But this is an aspect of authentication that we've neglected for many years. And how does that translate? Well, that translates in how we design protocols. You know, we have very few protocols that are deployed that are trying to blind the identity of the person trying to authenticate. That's a design decision. And why did we get there? We got there because until recently we don't care about privacy. I'm not saying there aren't counterexamples, but most protocols that you look at today, the signaling is explicit. You always see who is authenticating. The transaction itself may be encrypted, but usually the identity of the person authenticating is public. Yeah, to talk about the obvious, in SSL, for instance, everything is explicit. You always see who is trying to authenticate to what. The recent evolution is encrypted SNI, for instance, where you hide the destination of who you're trying to connect to. But that's a recent evolution in the protocol that most people aren't using yet. So, the means of authentication, if you dig down a bit deeper into the problem, so how do you actually do that authentication phase that we talked about? The traditional things are the 3 factors. So, who you are, so biometry. The problem with biometry is that this is a set of things that do not change and that you can't rekey. So if you were to get that compromised, you're kind of stuck with it. What you have, so usually a key or a 2-factor authentication token. And when I say a key, I mean a physical key, like something you actually have. Or what you know, a pre-shaped key, a password, a passphrase. So today, I'm mostly talking about what you know. And the reason for that is that this is what's practical to change. This is how most of our authentication protocol and architecture is organized. Most systems that we talk about are using something you know, a password. That's how 90% of what we've got deployed out there is. That's maybe not the sexy stuff. That's maybe not, the two-factor thing that we talk about. And I'll get back to that in a minute. But it's how most systems work. And if we don't want to change those protocols, the main thing that we can do is ask ourselves the question, what could we do better about passwords? And you'll see that there's a lot to do that we are not doing. So, before we delve into it further, we need to separate different types of authentication. We've got what we call online authentication and offline authentication, and those are fundamentally different requirements. On one side, you've got things where the person that is trying to authenticate it and the person that verifies his identity is on the same system and within the same scope of the same system. That means operated by an entity that you control. And on the other hand, you have something where it's not always the case. I'm simplifying here. Obviously, you have hybrid models. One of them I'm talking about later on, for instance, payments and card payments in particular. It's more of a hybrid model. But it helps when you conceptualize it to think of it in terms of interactivity. How interactive do you need that authentication phase to be? Sorry, I'm using a lot of acronyms. If you have any question, we're not many, just ask. FDE stands for full disk encryption. And then what we need to talk about and think about is authentication as a process. It's a phase. So it's part of a process. And really, in most of our systems nowadays, we've got alternatives. You've got the default way of authenticating to a service. And you've got fallback procedures. You've got sometimes even alternatives in terms of default way to authenticate. Like you will be asked whether you want to use your token or not use your token, use your phone, use something else. And all of these are part of the same sphere. And in terms of security, what matters is whether it's the weakest link here that we're looking at. And that's, well, the photo didn't render properly, but you've got a chain that is maintained with a big padlock that's maintained in place with a zip tie, the traditional meme. And when you think about authentication, you need to think about it as a whole. If you are providing plenty of recovery or alternative login methods, they all need to provide at least the same amount of security and level of security. Otherwise, you're doomed. So this was really the basics. And if I sum it up, what we should focus on is the properties you expect out of the authentication phase and the system. So one of them, and probably the most important one, is convenience. Because if it's not convenient, both to change, to deploy, and for the users to use, no one will ever adopt the technology or use your system. And we forget about that one way too often. And I'll get back to this. And that's definitely something we can improve on. The other one is efficiency. And efficiency means a lot of things. Efficiency means how efficient it is as an authentication protocol, but also how quickly you can perform it, and more generally speaking, the cost associated with running it. Then there is a notion that is also very important, that's balance. What do I mean by balance? Usually when you authenticate, there is at least two parties that sometimes belong to the same system, but there is the person trying to be authenticated and the person that is doing and performing the authentication, the verifier in the terminology. If the verifier is doing much more computation to authenticate someone than the client is doing to try to authenticate, you create a DOS vector. You allow someone to try many attempts with no computation required, many login attempts, and on the other side, you do very expensive computations to try to validate whether that attempt was legitimate or not. That's typically a scheme that's not balanced. That's creating attack surface for no reason. Another nice property that you may want, and that you usually want and that you don't get, is mutual authentication, where it's always nice when both parties are able to authenticate to each other, rather than you sending to someone that you believe to be the person you want to authenticate to without being able to prove it, your credentials. In that vein, one of the things that is super important and that you usually don't get is resistance against replay attacks. So if Alice wants to authenticate to Bob and Mallory or Eve eyes drop upon the transaction, you want to prevent Eve from reusing the same credentials or reusing the same process to get in and impersonate Alice. Resistance against pre-computation. So you want to prevent someone with resources in advance of breaching your system to be able to make the work easier on him after he's actually breached in. And then resistance post-compromise, where you want to create a system where even if it was to be compromised, no one would be able to reuse that information or leverage that information to do something else, including potentially re-breaching your system after a compromise. So all of these are very nice. Most of these you don't get in current protocols, or it's always a trade-off in between things you get and things you don't get. So that's just the basics. And stuff, we should all know. Now, I'm gonna go into cargo cult debunking, where literally we've been preaching things as InfoSec professionals that we shouldn't be. And more time than not, it's because they probably made sense under some threat model or in some environment that has just evolved, and we've never reconsidered what we were preaching. And that's a problem. So one of the things I hear all the time is that two-factor authentication is the answer to everything. If you listen to vendors, they're all pushing two-factor authentication. The problem with it, there are many of them. Let's go through it quickly. The first one, obviously, is that legacy is here to stay. It's always been a problem in IT in general. It's a problem in security in particular. And regarding two-factor authentication, it's an even bigger one. That's obvious. The second one that often gets overlooked is that passwords is usually one of the factors. And the security properties you get out of using two factors are neglected if one of them isn't actually a factor. It's obvious, but you need to state it properly for, people to register. Then, most systems have recovery processes that allow the requirements to be bypassed. And that's a side effect of what we've seen before, resistance to change and change of process from the user. If you adopt two-factor authentication, you change the way users authenticate with your system. And because you did that, odds are you will need to also have alternative processes for them to recover from that situation, because you will have some of them falling through the cracks. And the other one, and the last one that I've mentioned here, is that it doesn't scale. And why do I say it doesn't scale? It's not that it doesn't scale as a technology, it's that the technology isn't mature and widely adopted enough. That if you went ahead and adopted two-factor authentication, you would have too many fobs on your keyring. In between U2F, UAF, whatever, all vendors around the place are implementing whatever is the state of the art at any given point in time. But if you look in the last 4 or 5 years, you've had one new standard per year. Improving all the time, but just not ready for prime time. And what that makes me say is that, yes, it's probably something we should aim for. Is it ready? Probably not for all protocols. And what I really want to fix here is not just the high security, high standard things. It's also, the lower end of the pyramid. The fact that we have too many passwords and too many things we're doing wrong. I'm not arguing that two-factor doesn't have its place. One of the points I'd like to nitpick on, because that gets overlooked way too often, is that two-factor authentication isn't two-channel authentication. And many professionals don't make the distinction. I hope you do. To have two factors, you remember my slide with 3 different factors where you have what you know and what you are. You need 2 of these to have 2 factors. No, I've received a text message and I know the digit at that point in time. That's two-channel authentication. That's 2 times something I know. It's my password and the code that is on my smartphone.
So the idea is something you have the smartphone. That's how people interpret it sometimes.
It's how people interpret it, you're right. And it has some standing if you use, depending on the implementation, if you actually use a hardware element in the phone to ensure that that code can't be copied. It's a flexible, I mean, I agree. But in the way people are using it and in the common sense vocabulary, people use it interchangeably, and they shouldn't. Because there is a distinction here. So one of those that I hear all the time and I've got more and more problems with, including in my day job, because, that's what we do, passwords, is that passwords need to be secure. We say it all the time, and we say, as professionals, teaching our clients, you need to secure your passwords. What do we mean by that? Well, as professionals, we never agree on what we mean. That's why we've got so many ways of defining secure. And the problem that comes from it all is that we can't define it. And because we can't define it, and we have the expectations, we push the expectation onto our users to make the right choice. And that's an unfair thing to do. We're supposed to be the professionals and tell them. And that just doesn't work. So I've covered a few: strength, length, entropy, uniqueness. We have a zillion way of doing it, and we're not very clear on what that actually means. But taking a step back, have you guys ever wondered, why are we doing that? Why do we need passwords to be secure? I'm challenging you today. I mean, come up with a good reason for why we need passwords to be secure and in which case that applies. Yeah, but again, that's...
If the passwords I suppose I'm more falling back to the transport passwords now as opposed to the passwords themselves.
No, you're not. You're right. If you take NTLM hashes and Windows domains, because that's what you seem to be alluding to, you're right in saying that it's ridiculous that in 2020 we still have unsalted hashes from a fast hash function. NTLM is MD4. No salt, no nothing. It's ridiculous. I agree with you. But how does increasing the strength of the password solve that problem? It doesn't. On a Windows domain with a hash, you also log in. You don't need to reverse it. Find me a good use case of why we actually need those passwords to be secure. I'll show you the tool afterwards, and that's where I'm going on. On an online system, you never do. So NTLM on a Windows domain, that's an online system. On an offline system, I'm arguing that it somehow matters, and I'm going down to this by also reminding the basics. So offline password cracking. So on an online system, you just rate limited. And because you rate limited, the strength of the password doesn't really matter. If the attacker can't guess it within your rate limited time, he'll never get in.
As long as it's strong enough to resist the trivial first 2-3 tries case, I agree.
Yes, yes. But that's always the model. Or that's how we're going to get to the model. Now, in terms of offline password cracking, so the basic formulas are number of symbols, so the diversity of the password power the length. And that's why we like to say that if you increase the key space, that's the cargo code that we push a bit everywhere, you make it exponentially harder for the attacker. And that's true. But do you realize that the attack is completely asymmetrical? Like, as long as the attacker can parallelize the offline processing, you're always going to lose. It's just a matter of time and resources he's got to invest. And the problem is that under most threat models, and sane threat models, the attacker is not paying for the resources. And this is one of the things that has changed, and we as an industry have failed to adopt. just like technology has evolved, nowadays you can, bid for instances on Amazon, spot instance or whatever, for a fraction of the cost. Everyone has got a full cluster available that you can use with credit cards, or worse, with stolen credit cards. And all of that probably made sense when, the few institutions that could afford a computer were universities and mainframes locked down by physical security. That model makes sense back then. What sense does it make now? Which of your attackers that you care about can't spend enough money to actually crack your password? And how does that relate to, you imposing on your user to use longer passwords? So, of course, another factor here is what key derivation function you use. And I'm going to touch a bit more on this. So, if you increase the cost of each iteration, which is what we've been relentlessly doing in the security industry, trying to over-engineer functions that are slow, what you're actually doing is slowing down your system and enabling the attacker to turn the tables on you and conduct a DOS attack, because you just introduced a DOS vector. There's only so much you can slow down the process. Does that make sense? So, the new OfficeLike guidelines from the government and from various institutions advocate for different rules and different thinking. And it can be summarized as such. So, at least 8 characters, because that will defeat most attacks that are online. No composition rules, because these were encouraging bad behaviors. Uniqueness, so that covers the credential spraying and, most of the attacks where the attacker would get in on the first try or based on trivial passwords. And rate limiting. And it's great that, they're finally seeing the light and talking about this, because it's important. My personal take on this is that too many people are doing authentication. What we really should do is centralize the authentication step. There's plenty of good reasons for that. If you think about it pragmatically, all of the informations we talked about before are privileged, whether it's your biometric data, whether it's your passwords themselves and secrets, whether it's things you have. It's all stuff you want to keep secret. The more you disseminate it around to different providers, the less security you get. So,
sorry, going back one, how can you say that, unless I missed something entirely, that the new guidance prevents credential stuffing?
Because they encourage uniqueness.
Right, I just meant there's still a weakness that it may not be unique. Yes?
No, but the idea is that they force you to check against the blacklist of credentials that they know to be compromised. And that's easy. Just take the attacker's playbook. That's what my software does. And the software
I know that wouldn't be the solution. It was just I haven't seen any guidance from NIST, NCSC, or Microsoft pointing towards checking a known bad list.
It's in the reference at the end of my slide. They definitely do. Excellent. They do ask you to check specifically for uniqueness. They're a bit vague on the how, but and for those that are interested, that's what my product does for Windows domains. So let me give you a few examples of where it goes catastrophically wrong, and where we've pushed the wrong threat model and the wrong security controls as a result on technologies and on things where it just doesn't make sense. So the first one I'm going to have a look at is full disk encryption, because that's something that a decade ago very few people were using, and a decade later it's everywhere. Your phone is encrypted, your laptop is encrypted, everything is encrypted. You turn on Windows, it has BitLocker and everything by default, and you should be using it. The regulatory framework encourages you to use it, but you're not getting the security properties you want out of it. I'm speeding up a bit because I have been spending way too much time on the easy stuff. So, properties one would expect. Well, the first one is, I've lost my laptop. what happens now? I mean, what's the expectations here? I've paid the price, I've followed best practices, I've got a complex password, every day my system is slowed down because I'm doing proper cryptography, by opposition to using, hardware-assisted ROT13. What do I expect out of it? No one can recover my data, ever, right? We're using military-grade encryption on those things. And I'm typing my 25-digit passphrase every time I boot up. Well, in the real world, it depends. So let's look into it. I'm going to cover most of the landscape here. I'm sure you can find exceptions, but we can discuss it. Lux v1, so that's what you will most likely be using on Linux. There is a version 2 that does a bit better, but same idea. Firewall, so the macOS implementation, they all use password-based key derivation functions, which is basically an iterated version of the same thing. So it's always the same idea. I'm slowing down my key derivation function. And they use a very low iteration count. On Linux, it's 2 seconds worth of processing on the machine. On macOS, it's 40,000 in hexadecimal, if I recall correctly. In any case, it's an attack. It's something the attacker can parallelize. And because it's something the attacker can parallelize, you lose. It's just a matter of time and resources. But you're never going to win that fight. And increasing the length of the passphrase is not going to help you. It's going to increase the cost of the attack, but it's not going to save you. And we know how to do better. How do you do better? Well, one of the ways, and the ways I'm going to be talking about, is using hardware-assisted cryptography. But not the way Microsoft does it with BitLocker, because that way it's even worse. The way the TPM is used in BitLocker, the key, one of the keys that allows you, because there's plenty of keys on all those technologies, there are recovery methods. There is the main way you log in, which, maybe any combination of things, and there's always a recovery method. For those that are familiar with BitLocker, typically, you either use completely the TPM and it auto-unlocks at boot, or you enter a PIN, or you enter a secret something else. But in any case, all the key material you need, the VMK, is stored on the TPM. And if you look at the TPM, and if you look at the governmental certification for the TPM, so the FIPS certification of the TPM, it's a level 2 device. What does that mean? Well, FIPS level 2 means that hardware attacks are out of scope. How convenient. I mean, I've lost my laptop. So all the guy has to do is to take off the device and talk to it. He'll spill out the secret because hardware attacks were out of scope. That's the world we live in. That's what keeps forensic companies in business. And, sorry, I just went back. And we need to move away from that. I mean, it's just ridiculous. So, there's no reason for not doing better. And we're getting the worst trade-off possible. We're paying the resources. We have the technology. We have the hardware. We just have bad code that goes with it. And if you look at how we've stored passwords in the past, level 0 was you actually store the password. And you compare it. That's what BIOS have been doing for decades, where you had the BIOS in memory and you were just comparing it. Level 1 was store a hash. That's what Windows domain are doing. NTLM authentication. Then attacks improved, and we came up with rainbow tables and time memory trade-off compromises. And then we've introduced salt. But as soon as we introduced salt, that has negated some of the other security properties, where now you can't compare and you can't know if two users are using the same hash and the same password or not. And then level 3, which seems to be the state of the art of what we're doing nowadays, is to ever increase the slowness of the hash function that you're using. So most of the industry is stuck there, and improvements have been made. So, I mean, we moved from PBKDF and bcrypt So that's an iterated hash. That's a cache hard function in 2000, so 20 years ago, to memory hard function in 2009, that's 10 years ago, into what is currently state of the art, and that's again a cargo code thing that we're pushing nowadays. Everyone should be using Argon 2. Argon 2 ID, because that's the latest fad. It's true. But all of these do not prevent the parallelization of the attack. And because they do not prevent the parallelization of the attack, the only thing you're doing is providing the attacker with a denial of service vector. So how do you do it properly? Well, it turns out that level 4 is hash something the attacker won't have or won't have access to. And that's actually pretty doable. Phones do it. Phones are the only area that I know of with pay TV that is also a notable user of advanced cryptography, where they do it right. That has proven to defeat the FBI, where they literally spent millions trying to decrypt whatever iPhone and never managed. And we've got the technology. That's my next slide, and that's really the point I want you to leave with. It's super practical. It's just code changes. You change the code. That's all it takes. Your Windows-compatible PC has a TPM and has had a TPM for a decade. And odds are that's still FIPS Level 2 certified, so it might still not be good enough. But your CPU most likely comes with SGX. That's FIPS Level 3 certified. That starts to be hardened against hardware tampering. All you need to do is, instead of storing the key in the TPM, HMAC with a store a secret key in that hardware device, and HMAC the output of your key derivation function with it. Now the attacker can't run faster than the hardware device that's present in your device. No matter how many GPUs he lines up, he will always be bound by the speed of your TPM. And yeah, sure, he can overclock it, but that is several order of magnitudes slower than what you will ever be able to do elsewhere. That's not hard. I do that on my laptop. So should you. And so should everyone. So, it's just code change. Super cheap. Improved upon the security property. Stops the arm race where we're creating DOS vectors. One of the nice properties of PBKDF, by the way, is that the longer the passphrase, the longer it takes to run. Because if the passphrase is longer than the block size, and the more key material you need, the more you need to run the algorithm and the slower you get. So, stop the race towards requiring more entropy in the password, because that's really not helping you, and not really what you're after here. And there is nothing that says that you can't chain it. You can be using both the TPM and SGX and Argon 2 to harden your key derivation function. And if you do it right, you can get mutual authentication as well, where you can ensure that the TPM only unlocks if the specific hash has been presented. And if it doesn't present itself, then you can get the TPM to clear itself or do some other funky things that I won't be talking about today, but that I was doing. So that's the case offline. And if you look at the online case, which is, the one we're experiencing every day and all the time, I really need to speed up. So properties you would expect. Mallory, so we've got Alice and Bob and Mallory in the middle. Mallory got hold of one of the exchange. That used to be a problem before TLS. Surely no one can replay my data. Well, banking in the UK has had interesting technology for dealing against that. We'll go back to it. And then properties you would expect is also transport layer security and post-compromised recovery. So on the protocol part, most of the web is stuck either on HTTP basic auth or on just sending through post forms the password in plain text. I'm arguing that it doesn't provide replay protection. It's not a challenge response mechanism. We've got plenty of practical challenge response mechanisms implemented. TLS SRP has been standardized and exists and has existed for decades. No one has used it. Those technology exists, and we could use them, but we don't. Regarding replay protection, one of the things the banking industry in the UK has been doing, and that control has been misunderstood by many, is to ask you one character out of n in your password. The whole idea here is to prevent replays, so that if someone gets hold of that exchange, they won't be able to get hold of the next. I've put an asterisk because that's if it's implemented properly, and if we get there, I'll show you that sometimes it's obviously not. And then on the backend part, servers do get compromised, and we talked about it before.
One question, does it imply somehow that the password is stored in reversible form?
No. I mean,
how can you know the third character in the password if you know it's stored in reversible form as a password?
you can store the different permutations that you will be asking for. No, you don't actually, you can lose information. Basically, the idea of something that's not reversible is that you've lost information on the way. So you can use a Bloom filter, you have plenty of ways of actually ensuring probabilistically that this is the right answer that doesn't allow full reversal.
Usually it's a second set of data.
And usually it's a second set of data, it's not overlapping data. But both are possible. And then when servers do get compromised, because we get key recovery, we get attacks like credential stuffing that are possible, where the bad guy compromised one server somewhere and the user has reused his password on different websites, and the end result is that you end up with not doing the right thing. So on the protocol part, you need mutual authentication and encryption, transport layer security. So nowadays we have it, and a challenge response mechanism to defy replay attacks. Sorry, I'm speeding up because otherwise I won't get there. On the backend part, you could use the same KDF as what we've seen for offline attacks. There is no reason why your bank or whatever is not using HSMs or TPMs or whatever to secure the way they store that data. It's cheap and everyone should be doing it, and we should have libraries that allow developers to store passwords securely. And storing passwords securely shouldn't be use Argon 2. It should be mixed in with your TPM and whatever else. And if clustering or backups or whatever are a concern, there are solutions for that too. But fundamentally, you shouldn't be doing authentication. You should be using single sign-on. If you really have to, if you really have to, I can only strongly encourage you to look into zero-knowledge proofs and password-authenticated key exchanges. That's how they're known in the crypto literature. The very old protocol and standard protocol that has been very well documented is SRP. That's not what I would recommend you use today. The fancy stuff is OPAC that has a proof, or BSPAC that is even newer and has all the properties you would ever want. Post-quantum annoyance or resistance of some sort. And that will ensure that if the attacker gets the verifier on your server, so he's breached in, he's got the equivalent of the hash. It's not the hash, it's called the verifier in those protocols. He won't be able to brute force them without committing resources and an outrageously expensive amount of resources compared to classical cryptography and the slow functions we've seen. And that only requires changes on the verifier side. So it's actually very practical to implement those things. Payment systems. I'm going to skip because I'm already overrunning it. But I'm arguing here that payment systems are not doing what they should be doing. You have a smart card, you have a PIN. It's slightly out of what I've been talking about. I've been talking about passwords, and here it's another form of two-factor, but it's the same failure, basically. You can steal money from cards, if you haven't seen it this morning. You can pay stuff with it, whereas you shouldn't. And really what you need to look at is how those things have evolved. So level 0 was embossing a piece of plastic and just something you have. Level 1 was the same idea, go digital, add a MAC stripe to it. But the idea is still use the data that is printed on the thing and use that everywhere you'll ever do a transaction. Level, what I call -2, is when we decided, well, actually, all security model revolves around you having that piece of thing that we tried to make hard for you to copy, but we're going to allow you to make transactions without having it. The internet was born. And we came up with new interesting way of forgetting about the security model. And level 3 and 4 are the same thing. Well, we added a chip and an EMV, and then we decided that the wires were not necessary, so we took a protocol that wasn't end-to-end authenticated, and we decided, well, let's get rid of the wires, because that's surely gonna help people to, skim through cards more easily. If you really want to state the problem is that your card is valid for X years, and all the parties that have ever been involved in a transaction have access to all of the data, or at least enough of the data to make a transaction. Not all of the data. All of the data is not accurate. Enough for the data to make a transaction. And really, the obvious short-term practical solution is to make the data change for every transaction. And if you look at the history, that has happened when they introduced the CVV and then the CVV2 and then all the bits and pieces, now the counter or whatever in NFC. But without changing the protocol, they could have made the card number change. And the technology is out there. It's not deployed widely in the UK, but you can already have ephemeral card numbers that you can use only at one merchant, or where the issuing bank will verify that when it's been used once, it will link all the chain of intermediaries, and you will only ever be able to use that card number at that intermediary. So if the card is stolen and reused somewhere else on the payment network, the transaction won't go through. All of that exists. And all of that is controlled by the card issuer, because he's the one who gave you the card. And that doesn't involve changing all the protocols in the middle. So the sad story here is that the industry needs fraud to exist to sell you insurance, both as a merchant and as a user of the card. So that's why those things are unlikely to evolve, but it's never been about security. So, conclusions and takeaway, because I think I'm going to get kicked out. If you're in charge of authentication, you should reconsider if you've been asking the right thing from your users and from your vendors, both in terms of what you expect from your users and what the vendors have been providing you with in terms of technology. If you're a government, it'd be great if you realize that regulations you impose on people, like know your customer and all of that, encourage terrible security practices, because they make you disseminate information that you should aim at retaining and keeping private. It would be great if you were operating an identity provider that other people and third parties could use to authenticate and fulfill those requirements that you've imposed on them. And arguably, as a user, I'm not worried about my government using these, because they already decide who can open a bank account and who can do what or not. Yeah, you already have that data anyway. And if you're a user, you should help spread the word that better alternatives exist. You shouldn't let people force you to pick longer passwords for wrong reasons. Because really, you're a tiny piece in the whole machinery, and you're not going to change the threat model. That's the reference. I encourage that you watch at least this talk from Steve Thomas, who talked about Bespace at DEF CON. He introduces all the other pakes and why Bespace is better. I avoided math on my slides, so but it's interesting. Thank you. Before I close up, I just wanted to remind everyone that, cryptography does a lot of things, but not everything. Do you have any questions?
Yeah, I've known you how many years, and I just learned your next gens?
Right.
That's not a question, but just on that.
Okay. Well, if there's no question, I've got two more.
So the question is about when you said about the card can change. I think in the US they already introduced this called virtual cards. They change the current card numbers on the go.
Yeah.
I don't know if it's been
We've got it in France too. I mean, it's not super common. And the main thing you would really want is to have a terminal that generates you a unique card number that you could use for a different one for every transaction.
It generates, literally you use one transaction, it's a digital card, you just take a transaction, then seconds later your card number has been changed to a new one.
Yeah.
Everything changes.
That's exactly what you need, yeah.
So I saw that in demo.
But there are different ways of doing it. I mean, either having a different card number or having a card number that you tie to a specific payment chain so that you allow repeat transactions from the same merchant. That also defeats most of the fraud. Yes?
Does that not tie into what you skipped over at the beginning about convenience? The more secure and more measures you put in place, it impacts the convenience of the end user, and that's where they start to lose it.
But it wouldn't really. I mean, do you know your card number? I don't know my card number. I hand over a piece of plastic and...
The problems that you've got with people using card numbers, and I agree that the ephemeral card number system is a great way to start. But the problem that people have is that online shopping baskets and things like that, the convenience of it is that they want to store on particular card numbers to be able to pay them.
Yeah, but like I said, one way to solve that problem of changing card numbers, I mean, card numbers already changed because they have an expiry date. The cards, eventually they'll have to change. But to avoid having to change it each transaction, what you could do is tie in the merchant code that has been used, or the merchant industry, in your transaction, because as a card issuer, you get the full intermediaries and you know everyone involved, and just ensure that the card number is only reused for that specific, in that specific place, so that if someone else tried to make a transaction somewhere else in the system, it'll just get rejected.
Your processor offering services to some other third party and users to process your transactions. You just tokenize the whole card number for you, and then you don't have to provide it next time. You have the token, you provide the token.
Yeah, but they're doing it internally. The problem is that they're doing it at their level, and everyone else in the transaction still gets it.
True.
And if you look at breaches, it's not always the merchant you bought in or your bank that gets compromised, yet your card number is in the win.
Go for it.
30 seconds. Okay. So one of the few things I did want to show you guys. So the first one, here it's the French government, but I could have taken another example. I think I've taken Avibinpo. I encourage you to try your password online. Well, I've got news for you. If you put your password into a third-party website, it's compromised. You don't need to wait for that. Obvious, but you know. Another one in the UK where they're asking you both two forms of identifiers, your number and your surname, and then the password. That's because everyone else is asking 3 pieces of information, so they're also asking 3 pieces of information, but 2 of them are about identification. Why the hell are you asking 2 different pieces? You can't tie in my account number with my name? Need me to do that for you? I mean, no security there. Another one that I particularly love. People misusing the replay protection. So when on the login form, before they'll ask you your username and your identifier, they ask you 3 characters out of blah blah in your password, and they put the replay protection. That doesn't work. And why doesn't that work? Because you clear your cookies, you refresh the page, you'll get a different combination. If the attacker has captured one of the exchanges, he can just keep iterating until you challenge him for the same thing. He will win. And you will lose. And that's why the right way to do it is the opposite, is to first ask for the password on the first screen and then ask for that, if you want to implement the control properly. Another one, not so common in the UK, but in France it's been widespread in the financial industry. Virtual keyboard. The idea is a bit the same, and the control is a bit the same. The idea is that if you've got a hardware keylogger, if you've got some form of replay protection that you need, you change the place of the numbers on the display. But for the same reason, it doesn't work. You keep refreshing, and eventually you'll get the same keypad presented to you. Doesn't serve any purpose. Not to mention that hardware keyloggers I'm not saying they don't exist anymore, but, the banking industry has been faced against Zeus and Trojans being installed on computers. Not really hardware for a very long time. And Zeus can take screenshots. And the last one, but I'll let you think about this one. Password managers. Why are passworded Excel spreadsheets any better than, are they any better or any worse than a password manager? And I'm arguing that they're not. Because a password manager will auto-fill in your details on a website. So you'll transform the more mundane bug that you find everywhere, reflected XSS, into a zero bug permanent compromise of the long-term credentials. Your Excel spreadsheet isn't that good. That's my thoughts in closing. I'm well overdue in terms of time, so I'll leave the space to the next speaker.